want to thank everybody for being here today. First thing, we've got a question, which is a comment that relates to the last video we did but pertains to the next video we're going to do. So let's take a look at that comment. And this is from John Smith about the Dual M.2 NVMe PCI Express adapters. John Smith, let the M.2 madness begin. Of course, I'd personally like to get hold of the Dual M.2 card that comes with a Gigabyte Z590 Extreme. Curious as to why the high-end Intel 11th generation boards only get a dual M.2 card, whereas AMD's get a quad card. Well, I got to tell you, that's a good question, and I appreciate what John said. And we do have a part number for that dual card that Gigabyte has, but we don't have a SKU, and I can't find a listing for it. So unless we can find somebody that wants to sell one, there's no way we're going to get our hands on one. But as far as the dual versus the quad, that's all about resource allocation, and that's what we're going to talk about today, starting with the Supermicro. Now, this is a card we've had for quite some time. We didn't think it was relevant to talk about it, but the Supermicro Dual M.2 NVMe card. I'm going to take you now and show you that information as it relates to this card on Amazon. And the part number we're looking at is the Supermicro AOC for add-in card SLG3-2M2 for 2 M.2 PCI Express add-on card for up to 2 NVMe drives. So we're going to get this card out of the box. We're going to go overhead, take a look at it. We'll identify what we're dealing with, how it compares, and we'll be doing this as it relates to the system we've been testing with, which is the Gigabyte TRX40 Designare motherboard, which gives us 2 16-lane slots and 2 8-lane slots. And for this card, we're going to need one of those 8-lane slots, which is 4 and 4 for 2 drives. We've had some user comments that say they like to see an unboxing, so that's what we're going to do, is an unboxing of this card. Now, this is a server component, and that's important to remember because this is a server technology that's trickled down to the desktop that we now have access to. So I have a checklist of the product from Supermicro, and this states we have a low profile bracket, we have the box it came in, and we have the foam set, which is the foam that's surrounding it. There's the foam, there's the bracket, there's a couple of screws for the bracket, and that's the card. And I want to address some of the comments and questions some of you have had, not only for what we do on Build or Buy, but also some of the questions and comments that people have had in relation to this card on Amazon. I think a lot of people don't understand what it takes to make one of these cards work. Now, there are 3 types of M.2 cards. There are the style that support 2 M.2 drives, and we need to make the distinction and the delineation. There's one type of card that is a 4-lane card, and this is an 8-lane card, and that 4-lane card has 2 slots. One slot is for an M.2 NVMe drive because you have to have 4 lanes to address that M.2 NVMe. The other slot is for the other M.2, which is an M.2 SSD, which only requires 1 PCI Express lane. And what you'll see is a little connector somewhere on the board for you to plug in, because that is a SATA drive. So there's a difference in an M.2 SATA drive versus an M.2 NVMe PCI Express SSD drive. And whenever you guys hear me refer to this as either memory or as a drive, well, remember the definition of NVMe is non-volatile memory express. So when I call it memory instead of NVMe, it would be redundant to say both, but one and the same. But however, NVMe Express, or non-volatile memory express, means that's an extension of the PCI Express bus. So that's what we're getting ready to do. Just take a look at this card, put 2 sticks of memory on it, and I have specific memory I'm using for a specific reason for the next video that we'll do, where we're going to follow up the firmware as it relates to the M.2 drives for the WD-SN850 Black and also for the Samsung 980 Pro. And by doing these 2 different drives, and typically most of you, we're going to recommend both drives be matched and be the same, of the same technology, same speed, all that. But we're doing this for 1, proof of concept, and 2, because we want to show you some differences as we do this, because we're going to set this up and install it, put this on this card, put this in the system, show you the slot we're in, why it's there, go into the BIOS, look at all that. But then when we do the next video, we want to talk about the firmware as it relates, because these drives can be set up 2 ways. And for this installation, what we're going to do is set these up just as drives, just as bare drives. Now, if time permits, when I get finished, what I might do is go back into the BIOS and set up as RAID. RAID is not a function of the card. RAID is a function of the BIOS of the motherboard if it supports it. But there again, the motherboard has to support NVMe for you to be able to boot from it. So there's a chain of things that have to occur. If you want to put this in a machine that does not support a bootable M.2 NVMe, you can, but it would be just a data drive. So my point is, we can install these as individual drives, which is JBOD, another term for just a bunch of disks, or we can install these as RAID. And of the two options for RAID, one being with the operating system, the other being with the BIOS, we can set up and do a bootable RAID. Now that's a pretty cool thing. Now, as long as we were talking about high-end desktops and workstations, I didn't think this kind of card made sense. But with the X570 chipset, this card makes perfect sense because resource allocation. Now, the low-profile bracket is already attached, so we're going to take that low-profile bracket off and put the standard bracket on here, which is in the kit. We're in an anti-static bag. This looks like this has been sitting for a long time. And I don't know why we're not getting anti-static bags on our high-end desktop motherboards. But one of the complaints some users have about this are these standoffs. These are nylon, and the way they just snap in, I can use needle nose pliers, and you can see the way those are configured. Those will pop right out. And there's 3 positions, so they'll support 3 different sizes of drives. We've got the 2260, the 2280, which is typical, and then 110. So this support up to 22110, 110 millimeter drive, and those are already positioned where we need them. My other concern that I have not seen anybody else talk about is because of what if we put a heat sink on there? How's that going to affect when these drives are sitting up? So that's something else that needs to be addressed that we may do in this video or a separate video. Haven't decided yet. But I first want to test these and see what kind of a heat we get off of these. So 2 M.2 connectors, and we're going to look at the manual because this also is unique with this card. We have a couple of LEDs on here, LED 2 and LED 1, that will identify the drives to show activity, which is kind of nice. And looking at the part number, this PCB is made in Taiwan, Handstar. Pretty simple, pretty clean. And we also have a series of jumpers. The advantage of that is being able to let's take a look at the manual. Now, something I want to note at this point, this is identified in the specs as a Generation 3 PCI Express by 8. And I want to point that out because of the 2 types of cards that we're going to look at, there's bifurcated and non-bifurcated. Okay, this particular card is non-bifurcated, meaning it will require a motherboard BIOS that is bifurcated. So I want to make that distinction clear. The other type that is bifurcated means that there's a PLX chip. And how that relates to this information, if you have a PLX chip, the PLX chip determines the speed. So if this had a PLX chip, this would absolutely be whatever it says it is. But since we don't have a PLX chip, what we're going to do is put a couple of drives on here that are not only PCI Express 4, but they're 2nd generation, which means instead of going for a 3,500 megabyte per second drive, we're not going to a 5,000 megabyte per second. We're going to go and put a couple of 7,000 megabyte per second drives for proof of concept, because I want you to understand how all this works and how all this plays out, and again, proof of concept. Supports 2 drives, M.2 NVMe SSDs, which is different than 2 M.2 SSDs. We made that distinction. Supports Windows, Linux, and VMware. And I want to make that distinction because some of you will ask about some of these cards, can they be supported by a Mac? Some will not. This one says it does not. You've got to go to a card like Sonus Tech, or there's some others that we listed that are the quad cards, the 4-drive cards that do. Now, when we get into High Point, which are 4-drive cards, those can be supported on a Mac. But this card says specifically how it's going to work, so I want to relay that. And it shows the operating temperature up to 55 degrees centigrade. I want to see how the temperature plays out once we get this installed and up and running. Now, we're going to use the program we've used in the past, Hardware Info, and my understanding of the way that works is it calculates that measurement based on the formula for voltage to determine heat. If that's the case, and the reason I'm pointing this out, there's no way we can get the camera on here to get an emissivity reading because they have to be in the same plane. And we've already shown what happens when we use a ribbon cable. Those ribbon cables don't work. So the only way I could get the camera in to look would be this way, but if I did that, we wouldn't be able to see the camera. You'd have to take my word for what the heat reading is, and that was the point of that. So to reiterate, we'll show it with Hardware Info and accept those numbers that they tell us. Another advantage by installing the control panel software for either one of the drives we're going to use. That also will give us a reading of heat, but that reading of heat is not in real time. It takes a test and runs it, but it doesn't show it in real time. So pros and cons of how that's done. Now Supermicro also has a list of the server motherboards that this product will work in. And again, this is Supermicro, and we're going to put this in a Gigabyte motherboard. And it shows the different lengths of the media that it will accept. And what we want is the user guide that we're going to download right here. There's an explanation of location for the standoffs. We've covered that, and there have been some that complained about that. There's also an explanation of the front jumper locations and settings for JP1, 2, and 3. And the purpose of those jumpers, they're there to configure the SM bus address where this add-on card, the AOC, is detected by the BIOS. The default SM bus address is set to A0. However, it can also be configured to a different setting to avoid possible address conflict with another device installed on the same SM bus. Please do not change the default setting unless you are explicitly instructed to do so by Supermicro. It should never be changed unless explicitly instructed by Supermicro. So for those that want to know about the jumpers, book and verse, that's what it is. If it ain't broke, don't fix it. And if you were to contact Supermicro because you're putting this in a non-Supermicro product, guess what they're going to tell you? Yep. So let's install this. Anti-static bag. Always keep those anti-static bags. Documentation. Hang on to all that stuff. Now, the question comes up, how long should you keep the box or product came in? Whatever the warranty is, for the life of that warranty, keep that product. Because if for some reason you have to turn that product back over, you're going to need that box. You don't want to have to buy a box. So, hope that helps. So let's get this bracket out and swap this out. It's interesting having to do a bracket swap. We've had this kind of stuff before, but it's been a very long time since we've had to do something like that. But since we're putting this in a system and not a server, and if we were in a 2-unit tall rack mount case, or maybe 3, that looks like about a 3-unit. Yeah, a 3-unit tall rack mount case, that would fit just fine. But we need the taller bracket. And that looks like a number 2 Phillips. Now this card's ideal for an 8-lane slot. However, if you have a 16-lane slot, then I would definitely make use of a 16-lane slot. And a 16-lane slot would be a quad card, 4 drives. And we still have a video to do on 2 more quad cards. And we also have a 6-drive card we need to do a video on. We just haven't gotten to it yet. The problem with the 6-drive card, it has a PLX chip on it. So based on what we just told you, you kind of know where that's going to sit. But the technology we're still going to look at. Okay, we've got our brackets swapped out. Our standoffs are where we need them to be. So now we're going to put our memory on. Let's go to the next step. We're going to install a WD Black SN850. And yes, this drive needs a firmware update, especially for the X570 chipset, and especially if you're going to use it on the chipset instead of connected directly to the CPU. Hopefully that timing issue now has been problem resolved. First drive on, inserted. Now, at this point, if we were going to install a heatsink, the heatsink needs to be put on before the drive is mounted. And as we look at the clearance, there's decent clearance on here for a heatsink, but you'll notice there's one component on this card that could be a problem. So we have this much space to deal with for a heatsink. My other concern, because this is not a screw, but this is nylon, is going to be the weight of that heatsink. So we're going to test this as is, then we may test it with a heatsink. But this is the first step I want you to be aware of. I got to tell you, I've said this before, that's what I like about the Sabrent drives. They have a package that allows me to do what we do to change components out and still be able to store components safely and securely. I'm not wild about the containers that Western Digital or Samsung is using, but it is what it is. They didn't ask us. Most people install a drive and it stays there. We don't. Drive number 2. First drive down. Then we have the little pin. And I will take that pin, push that right in. That's all of that. Second drive. And it's got a little bit of a indentation on it, so you'll know where it rests. You can feel it. And again, the same thing. I'll take that pin, insert that, push that in. Interesting enough, not the same, but ASUS has also gone to a nylon type pin instead of the metal screw that's been such a hassle to deal with. And it's secure. It's long enough that it goes through and you can just see it tapping through on the back side. So they could have made it just a hair bit longer, but for security, we're in. We're good to go. So we have a WD Black SN850, and we have a Samsung 980 Pro, both PCI Express 4.0, both second generation, both capable of 7,000 megabytes. And then, of course, the next thing we're going to do is, once we get this in the machine, then we're going to want to test it, see what kind of throughput we get on the card. Now, any extra parts you've got, since we put this regular size bracket on it, hang on to those parts and put them in the box unless you've got a special place to keep stuff like that. On a side note, for those that are interested, the magic of video, of those that are interested in the Gigabyte TRX40 Designare, we've just done, on a side note, another build for one of you guys, and that was for Nathaniel, and we built that into a case that was not supposed to house an XL ATX motherboard. So 3 things we learned about that case. We may do another video about it. I'll just say, man, that was a treat, but his system's up and running. He's happy, and so we are too. So let's get this card in. Okay, to reiterate what we're working with, we have 2 16-lane slots, 2 8-lane slots, and because of everything we've done, we have the video card down here in the second 16-lane slot, and this is an EVGA GeForce RTX 2080 Ti, 2 slots wide, so we still have access to that slot. And because we've done the firmware update to the Thunderbolt card, we've uncoupled, so we no longer have this PCI Express bus prioritization issue, which means we can now put the Thunderbolt 3 card either in the first 8-lane slot or in the second 8-lane slot because we've uncoupled it. And we have right now a quad card, which is the Gigabyte Aorus that comes with the motherboard, in a 16-lane slot, which allows us to have 4 M.2 drives. That right now is the boot drive. And we're going to put this other card right down here in this last slot with these 2 drives, 8 lanes. And that's the advantage of having plenty of PCI Express resources, 2 16-lane slots and 2 8-lane slots. To reiterate, right here's that card, right next to the video card, right next to that fan. So if we had a thicker video card like the RTX 2080 Ti, we would have a problem. We'd have some hard choices we'd have to make. But the only thing better than this is going up to the workstation, which is the WRX80. But right now, I still think this is the best bang for the buck. Card is in the slot, secure. Now, we need to get everything else hooked up. So, we have to have a keyboard and a mouse. And I will plug in the network. Then we're going to have video so we can see what we're doing. And we go DisplayPort out to HDMI. And then power. And what we're going to do now is we're going to go into the BIOS, take a look at this, see that the drives are seen. Then we'll go into the operating system, see how the drives are seen. Then we'll do our test. Now these drives have been used before, so they need to be probably reformatted before we do anything with them. We'll check. Okay, we've energized the system. As soon as we get into the BIOS, I hear a post. That was something else I pointed out to Nathaniel. All the new cases do not include a PC speaker. I'm old school. I like a PC speaker. And by the way, welcome. My name's Gil Boyd. This is Builder Buy. I want to thank you for joining us. Now the first thing we're going to have to do is go to Settings. We're going to go to I/O ports. And because we are in the second slot, the PCI Express by 8_2 bifurcation, according to the instructions, that can work, but by example, it does not work. And for those that are wondering what BIOS we're using, I'll do F2. And this is the TRX40 Designare. We're on BIOS F4Q. So this is motherboard revision 1, but the same information would apply and be applicable to the revision 1.1, 1.2, and 1.3. And we can take a look. Our SATA, our PCI Express, we see our cards, and we're seeing PCI Express 4.0 by 4 at 4.0 by 4. So we've got to bifurcate that slot for us to see 2 drives. And the M.2, that's for the 4 on the motherboard, and there's nothing on the motherboard. So F2 will change that slot from auto to 4 by 4. If you'll notice, it's auto by 8 or 4 by 4, because remember that's an 8-lane slot. We have 2 M.2 NVMe drives, and each drive requires 4 lanes. 4 lanes, 2 drives. Now that that's set, we need to F10 reboot, and the BIOS will show us the one modification we did, PCI Express by 8_2 bifurcation from auto to 4 by 4. We will reset, and as soon as the computer comes back, we'll go back into the BIOS. We'll be in business. Again, in case you didn't understand that, this card is of the type that requires motherboard bifurcation. The cards that are self-bifurcated have a PLX chip, and that PLX chip determines the speed. Because here we go, back into the BIOS. We have three components we're dealing with: the card, the memory, which is the M.2 NVMe drives, and number three, the bus of the motherboard, which is the chipsets, PCI Express 4. So if the card has a PLX chip, that PLX chip determines the speed. If that PLX chip is not there, like this card, just a plain card that requires motherboard bifurcation, then the speed is determined by the speed of the motherboard and the speed of the drives that are on that. That's what we're going to show. Back in the BIOS. Settings, I/O ports. We now have that set to 4x4. Let's do F2. Let's look at PCI Express. And that's interesting. That says PCI Express by 8_2. PCI Express 4.0x4 at 3.0x4. Well, I did not expect that card to have a chip on there to control the speed. It does. So that card is PCI Express 3.0x4. What that now means, those drives that we put on there, because we're limited by PCI Express 3.0, that's good for up to 3,500 megabytes per drive. So we have 7,000 megabyte drives, 2 of those on this card, and apparently there's a chip on here that prevents that from going to PCI Express 4.0. I didn't expect that. Learning experience for both of us. Okay, we'll do F2 to go back to the regular menu. Let's go to boot and see if we see those drives. Nope, those drives are going to have to be formatted first. We're not physically seeing the drives. Let's press enter on boot option 1. We don't get a boot option 2. So that tells me we're not seeing those 2 drives. We'll go to I/O ports, another place we can look. Let's see if RAID Expert sees those 2 drives. Controller management, view controller information. We see 1 controller, but we see 6 physical disks. So those other 2 drives are now showing up. That's what I wanted to find out. I'll escape that. Let's rescan for disks. And we see 6 drives. 4 drives online, 2 drives that are legacy. And this says they are generation 4x4. That says all of those are generation 4x4. So I don't know about you, but I'm confused. So we have array 1, RAID 0, which is 8 terabytes. That's the 4 drives that are on the RS Quad card. Then we have array 2 non-RAID, which is 1 terabyte, and array 3 non-RAID, which is 1 terabyte. So that's those 2 individual drives. So the drives are seen. So what I want to do now is go into Windows and see if the operating system sees those drives and reformat them. Let's go look. So we didn't do anything, but if we wanted to, what we would have to do is go to Array Management, Manage Array Properties, RAID Array 1, view the associated physical disks, and that's the 4 drives, each 2 terabyte. That's a total of 8 terabytes, 7.9 to be specific. I'll escape that, and I would have to delete an array, which would be array 2 and array 3. Those have to be deleted before I can create a RAID array and put them in it. I'm not going to do that right now. I just want to show you what's what, but that's where that would occur. So we're going to go over to F10. We didn't do anything but look. We're going to save. We're going to reboot the computer, go past the BIOS, go right into Windows, go to Disk Management, take a look at those 2 drives. Because the first thing we're going to do is set those up as JBODs so we see the 2 drives. Then the second thing we can do is set them up in RAID if we choose to. What I'm curious about is I want to know the speed of the drives. Based on the information the BIOS said in 2 places, one place it said it was PCI Express 3, the other place in the RAID array said it's PCI Express 4. My expectation was PCI Express 4, so what I want to know is that a bug in the BIOS or is that fact? We'll test it, we'll verify it. Hope you guys are enjoying this as much as I am because I think this is fascinating. I've never installed one of the 2 drives card, this is the first, but I want to start with the Supermicro because it's a server component. Windows, here we go. And no, this is not Windows 11, it's Windows 10. Control panel, administrative tools, computer management, disk management. And the drives have been used before, and there they are. Otherwise, a dialog box would have popped up asking us to format them. So we have a 1 terabyte WD black, and I've already labeled them because they've been in other machines. And disk number 2 is a 1 terabyte Samsung 980 Pro. So let's test, see what we've got. Only way we're going to know. Now, if these were brand new drives, to reiterate, a box would pop up and we'd have to format them. That's already been done. These have been on other machines. So let's go straight to Crystal Disk Mark. And since these are 1 terabyte drives, we will set, according to the drive, we will select either one, D drive, knowing that's a 1 terabyte drive, so we want to set that to a 1 gig, and let's test drive D. But to double check again, what was our drive letters? The drive letter assignments. We can just go to the PC. Okay, the WD black is D drive and the Samsung is F. That's what I wanted to find out. So we're going to do D drive, and that's the WD Black, 1 gig, 1 terabyte. Let's test. If we get 3,500 megabytes, then we know how the card is being read. However, if we get around 7,000 megabytes, then we know how it's being read. Fantastic. So that's an issue with the way the BIOS is addressing the card. Those drives are seen as PCI Express 4.0, which was my expectation. And the point of all this, everything we do, I'm going to keep this screen up. I don't want to move it while I talk because I want you to see the numbers in real time. The point of this is no matter what we think we're looking at, no matter what the specs say, we have to test and verify. And that's what we're doing. So if you've seen one of these cards and it says PCI Express 3, it should not be that way as long as it does not have a PLX chip. To reiterate, if there's a PLX chip, the PLX chip determines the speed. The higher end cards use one brand of chipset. The lower end cards, like the desktop cards, use I hate to say a lesser chipset, but something like AS Media. And there are cards in this classification. There's one we may take a look at that uses an AS Media chipset, so we can talk about that, how that chipset is programmed and what it does for the uplink ports and the downlink ports. Those PLX chips make those cards expensive. I'll just say that right off the bat. These less expensive cards that don't have a PLX chip are just an I/O card. And again, to reiterate, this is the WD Black SN850, and no, we have not done the firmware update yet. That will be a separate video. So we've seen in the BIOS 2 places. It's also interesting as that drive is being accessed. I'm going to take that away for just a second. As that drive is being accessed, we can see that LED blinking for that drive right there. You'll see where I've got the screwdriver pointing. So that's kind of a neat item. The other cards that are more consumer oriented will not have that. This being a server or enterprise type product, it does. I just wanted to point that out. Well, that's not so hot, but almost 7,000 megabytes on the read, 5,000 megabytes on the write. Will that be helped with a firmware update? I don't know. But when we do the firmware update, we'll run the test again. Now, the other thing I'm not doing while this is running is checking the heat. I need to install hardware info and do that, but I want us to stay focused on one thing right now while we do this. And what we will do is probably address the heat issue in a separate video so we can keep this tight. And as soon as these numbers are finished, I'll come back because we need to run the test on the other drive. So we'll keep that in mind. Just under 7,000 megabytes on the read and just a hair over 5,000 megabytes on the write on the WD Black SN850. And right now for the Phison controller that's being used, I think we're at the limits on how fast these drives can go until we step out and go to PCI Express 5.0. It's coming. Instead of 7,000 megabytes on a drive, second generation, those first generation PCI Express 5.0 drives are supposed to be 15,000 megabytes per drive. That's wicked. Intel first, 12 months later then AMD. I guess your option is, do you want to be first or do you want to be fastest? That's one way to look at it. Okay, we have our numbers. Now let's run the test on the other drive. The other drive being the Samsung 980 Pro. So we'll go to the F drive, and then we're still at 1 gigabyte. And let's test and see how we compare. And while the test is running, if you notice, you can see that little LED is really getting busy down there, right there. The WD Black SN850 is just a hair bit faster. Good to know. And my expectation would be if we were using the 2 terabyte drives, because we have denser memory, we would also be faster memory. In other words, we should get a little bit better reading on the 2 terabyte drives. We've probably been using the Samsung M.2 NVMe drives the longest, have the most history with them. The WD Black, you know, we have the most history with the WD Black on hard drives, but Western Digital having an M.2 NVMe, that's a new animal. That's a new feature. So that's a new experience to get used to. So just under 7,000 versus just under 6,500. Interesting. Now, if we were to change slots, would that affect those? I don't know. It's a possibility. Our goal number 1 is to demonstrate this card. Number 2, explain what this card is about. Number 3, identify the system it's going in and the resource allocations, how it works together. And I think we also learned something else about how that card and those drives are seen in the BIOS of this particular BIOS, of this particular revision, of this particular motherboard. So pretty good. We'll wait till it finishes before we stop. And yes, that LED is still getting with it, or was, right down there. Now the system we just built for Nathaniel, if I remember correctly, I believe we installed a Samsung 980 Pro. That was my suggestion, and I still think it was a good idea. Like I said, we learned 3 things on that I'm interested in sharing with you about the case we used. All I'll say right now, it was a Lee & Lee case, and it was not designed for XL ATX, but we made it work. And those are the numbers, and that's what we have for the Samsung 980 Pro. Just under 6,500 megabytes on the read, and just a hair over 5,500 megabytes on the write. So now we have proof of concept. We know, number one, the card works. We bifurcated it, number two. Number three, we also know that we have PCI Express 4 on that card because the card is just an I/O card. That was another thing I wanted to point out to you. When I saw those numbers in the BIOS, I was like, well, wait a minute, I didn't expect that. But the test verifies, now we know. So as it goes, I think we pretty well covered it. Now in this next video, we're going to take a look at another M.2 card that a lot of people have been interested in, and I believe it's the one by Cable CC, I think is the name of it. They have a 2-drive card and a 4-drive card. We're going to take a look at both, and we still have another 4-drive card to look at. So I want to thank you guys for watching. We're on to the next video. We're out.